Now in today's notes, we're going to be graphing inequalities again. We have a little bit of an additional twist to it. I want you to notice that they are now in standard form rather than having them in slope-intercept form. So there is a little extra work that we got to do before we can graph it and go ahead and solve it. So let's take a look. The first thing that we want to do is, when we talk about how do you graph an inequality with the symbols less than or equal to or greater than or equal to, we want to go ahead and determine, is it a solid or a dashed line? So I hope that you noticed that in this particular case, we actually have a less than or equal to. So therefore, we are going to have a solid line. Now, it says, do we shade above or below? Well, we will figure that out in just a minute once we justify our answer. So that one, we're going to wait for a second. Now, let's go ahead and rewrite this equation over here, because we need to go ahead and solve for y, which means we're just setting it to slope-intercept form so that it's easy to graph. So I have negative 2x plus y is greater than or equal to negative 1. And what we want to do is I want to get y all by itself. So first I want to move this whole term over. So I'm going to add it, not divide. I'm going to add because I want to move the entire term over to the other side of the equation. So when I do that, this becomes 0. I bring down my y, and it is positive. And then I go ahead, and I can't put these two terms together, right? Because I can't combine them because they're not like terms. So I'm just going to rewrite it as 2x minus 1. Now, I have successfully changed this into slope-intercept form, and we can graph that. Now, today we're doing a little bit different. Instead of graphing by hand, I am going to go ahead and we're going to graph it with a calculator. So let's go ahead and practice that. So I'm going to turn this on. I am going to go ahead and go to graphing, which is this bottom function. It looks like a little U. And we're going to treat this as if it was an equation. We're going to say y equals 2x minus 1. So I'm going to put in 2x minus 1. So whatever's on the right side of the equation, because remember f of x just means y. Hit enter. And I'm going to hit Control T. And this shows me all my points. Now notice you can see my y-intercept, right? We know we had a negative 1 for y-intercept, and this shows 0, negative 1. I always like to plot the y-intercept first. So at negative 1, I'm going to put a point. Then I'm going to find one more point. Well, look, here's my favorite point, 1, 1. So we're going to use that one. So I'm going to come over, put a point at 1, 1. And then I'm going to go ahead and I am going to draw a line through these 2 points. And it is going to be a solid line. So draw a solid line because we have that less than or equal to sign. Once we got this done, we're now going to go ahead and pick a point on one of these sides and try to justify our answer. Now, unfortunately, I cannot pick my 1, 1 point, right? Because it's being used and the line's drawn through it. I always recommend do not pick a point on the line. Pick a point on one side or the other. That's a very small numerical value to make your math easy. So I'm going to go ahead and instead of 1, 1, I'll go to the next best one, which is right here. I'm going to pick 2, 1. That's going to be my test point to see, is this the side I'm going to shade? So I'm going to rewrite my equation. I have y is less than or equal to 2x minus 1. Now what I'm going to do is I'm going to replace my x with the x value of 2. So this becomes a 2. And I'm going to replace that y value with that 1. So now what I'm going to do is bring down my symbols and the rest of my numbers. And we're going to do the math. So let's see, I have 1 is less than or equal to 2 times 2, which gave me 4. And then we have minus 1. And if I continue to do the math, I have 4 minus 1, which gives me 3. So I could ask myself, is 1 less than or equal to 3? And yes, it is. That is a true statement. I'm going to write true beside it. And I'm going to go ahead and shade the, what I would say, below my line, or to the bottom right side. So we're going to shade below. Let me go ahead and do that. Alright, now I want to go ahead and find one on this side that's false, just to go ahead and verify that I did my math right. You never know, anybody can make a mistake. So I'm going to pick another easy point. How about I'm going to pick 1, 3. over here. Because everything on this side that's not shaded should not be a solution. In other words, everything over here should be false. So I picked 1, 3. Those are small numbers, easy to work with. So y is less than or equal to 2x minus 1. And I'm going to go ahead and get my x and y value. My y value is 3, so I'm going to replace y with a 3. And then my x value, I'm going to replace it with that 1 minus 1. And let's do the math. 2 times 1 gives me 2 minus 1. And 2 minus 1 gives me 1. And I have a statement of 3 is less than or equal to 1. And I hope you notice that is false. It's not true. So we know that we did it right. We got a true answer, right? And we confirmed by checking a 1 over here to make sure that it was false. So now I'm going to go and put my solution set. The one that I chose to use was 2, 1. So my solution set was 2, 1. But remember, any point that's on this side of the graph or below the graph would have given you a true statement. Let's go ahead and look at our next problem. On the next one, once again, notice we are given an equation in standard form. I do want you to realize that this time they're giving us a less than symbol. And if it's a less than symbol, we do use a dashed line instead of a solid. And then once we get this converted to slope-intercept form by solving for y, we'll go ahead and graph it and then use a test point to see do we shade below or above. So let's go ahead and take a look at this. Let's write this over here. So we have x minus y is less than 5. So we're going to go ahead, and first thing I want to do is get my y by itself. So I'm going to subtract this term and move it over. That leaves me with 0 right here. I'm going to bring down my negative y. And then I have negative x plus 5. Now, what I hope you notice is that we still have a negative y. And remember, we cannot have a negative coefficient for our y if it's in slope-intercept form. Because slope-intercept form is y, which is positive, equals mx plus b. So we need it to look like this. So what I need to do now is divide out that negative coefficient of 1. And I need to do it on both sides. Everything gets divided by negative 1. So negative 1 can go into negative 1 one time. And remember, a negative divided by a negative is a positive. Now since we are divided by a negative number, we have to flip our sign. So the inequality symbol gets flipped. And then I have a negative divided by a negative. That gives me a positive. And a positive divided by a negative gives me a negative. So now I can use this to go ahead and graph my lines. So let's go ahead and do that. So I'm just going to treat this like an equation so we can get our points. So I'm going to get back out of this one. I'm going to hit delete, get rid of it, and I'm going to hit tab. There it goes. Alright, so we have y equals x minus 5. So I'm going to put x minus 5, hit enter, and here we go. So notice I have f of x is equal to x minus 5, hit Control T. Here's my points. Now notice I do have a y-intercept of 0, negative 5. I always like to graph by starting with my y-intercept. So I'm going to put a point at negative 5. And then I'm going to go down to 1 and negative 4. So over 1 and down to negative 4. Alright, so now we can go ahead and draw our line. So we're going to do that. Notice that we do have to have a dashed line, right? So let's make sure this line is dashed. Perfect. And now that we're done, we just got to pick a point on either side to go ahead and try it out and see which one makes a true statement. Alright, so let's go ahead and we're going to write this equation down here. Y is greater than x minus 5. And let's see, I'm going to pick my favorite point, 1, 1. We're going to test it. So when I test that, I'm going to write my x value of 1 in place of this x, and my y value of 1 in place of this y. So what I end up with is 1 is greater than 1 minus 5. If I do the math, 1 minus 5 is going to give me negative 4, and that is a true statement. Now, on the other hand, right, we know that this side's going to be shaded now. So I'm going to go ahead and shade it right quick. That means any point in here is a solution. So I'm going to go ahead and prove that any point over here would be false. So let's use an easy one, like we can use 6 and negative 1. 6 and negative 1. Let's test that one. Y is greater than x minus 5. And my x is going to be 6. And my y will be negative 1. So 6 minus 5, that's going to give me 1. And we'd have 1 is greater than, negative 1 is greater than 1, which would be false. Now I do want to show you something. If you weren't sure that you did the equation right, if this is true, if 1, 1 is a solution set, I could plug it into the equation even in this standard form and it should still work. Let me show you what I mean. I just want to give you an example. You don't have to do this, but this is just something for you to watch and learn. So notice that my x value is 1, right, in my solution. My y value is 1. And I have 1 minus 1 is less than 5. 1 minus 1 is 0, and 0 is less than 5. It still rings true. So even if I just substitute the numbers into this equation without even changing it, I can still find a solution. The only thing is I won't be able to graph the line without converting this. So let's go ahead and let me write my solution set I chose, which was 1, 1.